Hi everyone. Well, it's good evening, so it's evening over here in the UK at the moment. Thank you very much for joining. The title of the talk is Kafka, DevOps, and Resilience for All. So, what do I mean by this? So, I'm using kind of DevOps as a bit of a lazy way to kind of catch all of these kind of modern software delivery techniques. You know, GitOps, infrastructure as code, config as code. Basically this basket of all of these different kind of techniques and how we can apply that to a Kafka cluster, because it's quite easy to kind of just overlook overlook Kafka and just say, well, it's just a message bus, who cares, kind of thing. So what I'm going to do is I'm going to talk through I'm going to do a little bit of a Kafka primer. I won't spend too much time on that because I had no guarantee as to who would turn up, and I've already seen that we've got some of you folks who are out there kind of running Kafka in prod. So hopefully what we'll do is we'll pick up some hints and tips along the way of mistakes I've made. I'll be brutally honest. And some of the tools that we've got to kind of get around that, in fact, and then go on to the kind of the why, what, and the how. So, you know, why do I need to think about this stuff? What do I need to think about? And how can I implement these ideas? So some tools and some different tips and tricks. So a little bit about me. I'm based in the UK. I've had a career in finance, and I work for a company called OpenCredo. We're a boutique consultancy in the UK. We mainly deliver in kind of data and graph, cloud native architectures, and platform engineering. So what that means is that actually this talk will hopefully be somewhere in the middle of those three different disciplines that we have. So without further ado, thinking about Kafka, so what's the difference? You know, I do hear some people kind of go, well, it's just a message queue, who cares? But the posh term, which is a very English word, the posh term for Kafka is it's in a append only immutable event log. So you've got an ordered sequence of events, a queue by any other name, yeah, and that is immutable. You write to the end of the queue, so a producer will write to the end of that log and keep writing to the end of that log. And one of the key differences between Kafka as an event sourcing platform versus a message queue is that you can have multiple consumers within that data, and they can be blissfully unaware of each other, because Kafka will keep track of where you have read up to within the stream of data, within that ordered sequence of events. What's great about this, and why am I such a kind of a paid up member of the Kafka fan club, is that we can create architectures that piggyback on Kafka's scalability. I mean, it came out of LinkedIn, and you can do all sorts of interesting data sharing use cases like choreograph microservices, or you can use it as a data bus, or Confluence, say, as a digital nervous system. They have this kind of concept of it being the backbone of the data throughout an enterprise. Key concepts to kind of bear in mind is that Kafka is a multi-node cluster, and that gives its resilience, its horizontal scaling. The offset, where you've read up to within a Kafka topic, that can be managed by Kafka. And that becomes really, really powerful as well. But we'll look at some of the pitfalls around offset management a little bit later on as well. Another interesting or a key concept to think about is partitions. So a topic within Kafka is physically divided into partitions. And Kafka makes one guarantee around partitions, is that as data is written into a partition, its order is preserved. And we'll see what that actually means in terms of your application architecture, or applying DevOps to this kind of stuff. And partitions also enable scale out as well. The other thing to bear in mind at the moment, and they've just had a recent milestone on this, at the moment, you also have to have a Zookeeper cluster as well. So there is yet another moving part to your Kafka cluster, but they've just recently got a working version where they've pushed Zookeeper data down into Kafka, so it's actually simplified that deployment, but I don't believe that's seen the light of day just yet. So if you have worked with Kafka, that's the kind of the primer out of the way, by the way. But if you have worked with Kafka, you might be sitting there saying, well, look, Kafka creates topics automatically on the fly for me. I don't need to worry about DevOps. Hopefully that's being said by no one, but it might be. But so what? So what if you leave that config up to Kafka? Config affects performance because Kafka's got this really neat way of being able to kind of configure a topic by topic. You can tune a topic for performance, but you can also tune it for resilience, for instance. So you really want to be thinking about what it is that or how you are configuring those topics and making it consistent across all your environments. But what if you leave it up to Kafka's defaults? What if the defaults change? What if the defaults are different for different environments? You might have, this is a horrible place to be if you've got a different version of Kafka. Each of your environments is some kind of magical snowflake. That's not a good place to be. I always think back to the kind of the mythical SRE guy or person that's at 3 o'clock in the morning that someone's kicking out of bed. Yeah, Alexander's nodding. He's staying up tonight because he has to be up he's on call. The mythical SRE guy or even the developer, getting kicked out of bed at 3 o'clock in the morning. You want to make that 3 o'clock in the morning call as easy and painless as possible, and hopefully some of these techniques will actually give you some of that. And when I think about architecture and I think about my applications, I think about the 12-factor application. And one of the main things is one code base, several deploys. So how can I boil my config down and materialize my config into a point where I can make sure that I can just have that all in Git, and I'm just blasting it out into different environments. So hopefully you're sitting there thinking, I'm interested. What can I DevOpsify? If you'll pardon me for making up a word. Broker setup. We'll look at security coming up in a few slides' time about how to kind of set that up. Server.properties. I was at a conference a few years ago and somebody stood on stage and they said, it's a really great idea if you take, for example, something like Kafka, when it's box fresh, when you just downloaded it, you take its server.properties and you stick it straight in your source control, because then this is the baseline. This gives you your baseline. And when you apply any updates to that, you can then track why you've made those updates, because hopefully you're going to have a Jira ticket or, Bugzilla ticket or whatever it might be, that you've got the traceability as to why you made that change, because you really want to do that. Come back to our 3 o'clock in the morning call. You want to know precisely what config is running. Other things that you can look at, putting DevOps rigor around, topic setup and partitioning. So I said earlier that partitions affect ordering. And if they affect ordering, they also affect your application behavior. So a few years ago, I was working at on a MiFID II project in London for a French bank. And we hadn't really paid attention to the partitioning strategy. And what we found is that we were getting updates for trades before we were getting the original trade image itself. And so therefore some of our logic was kind of all over the place, and we were getting negative amounts for trades because we were taking one away from the other. Now the fix is pretty straightforward to do, but it's a lot easier to fix that before you go into production, as I learned to my cost, rather than once you've pumped a few thousand trades through something. Yep. Next thing is kind of tuning Kafka on an individual topic basis, because when you set its defaults, you say, hey, a new topic will have these kind of defaults, but tuning topics on an individual basis for durability or throughput. If any of you are in finance, the example I always give is kind of prices versus trades. Prices, I want that to go really, really quickly through the system, but trades, I can afford for them to go slowly because I can't lose a trade, because guaranteed that trade you lose will be the $10 million trade of that day. And if you're actually tuning your if you're tuning your cluster, you can actually tune it for being able to support rolling upgrades as well. So if you change your kind of replication factor or how many kind of in-sync replicas you need for a particular cluster, you can actually add in a little bit of extra redundancy, which will allow you to do a rolling live upgrade. So hopefully that's good. We know we want to do this stuff. We know why we want to do it. But what are the options? So there's kind of three categories of options on the table at the moment. So it's Bash. The whole world runs on Bash. People in the DevOps world, it's either Bash, Python, or Ruby, or something like this, or Go. But Bash is a perfectly fine choice, and I've got some tips and techniques on that. There's a Terraform provider, or there's a number of Terraform providers, and there's also our good friend Duke, who is socially distancing from the other icons in the slide. There's a Java client that a friend of mine wrote that I want to introduce you to as well. So Bash, you can roll your own, and that will call Kafka topics. It's a good idea, though, if you're going to write your own script, and it's a perfectly decent solution, is to have your configuration declarative. So there's a little bit of Bash there on the screen there. So topics equals inventory.0 is the name of the topic, and that naming convention I'll come back to in a few slides' time. The first figure is the partition count, the replication factor, and then the number of in-sync replicas. So what that means is if you've got that in one place, I can go into source control and I can see what is the list of topics and how are they set up, and how are they set up under a labeled version of my build as well, rather than relying on some kind of defaults which might have changed over time as well. So you might not know what the defaults were when your topic was created. So the next option is Terraform. There are a number of Terraform providers, but not all of them give you the same, are not as feature rich or they're not all as feature rich as each other. But you really want to be thinking about changing your topics, your access control lists, and your TLS config. So for us, most recently, we were provisioning a Kafka cluster in AWS. We were using MSK. Now the thing was, we were doing it was a microservices estate with it was managed by Kubernetes for scheduling, and we wanted some infrastructure as code for MSK, and so we didn't want to expose Kafka, the Kafka platform to the outside world because it was private to our client. We didn't particularly want to have the Terraform state on a storage node within the Kafka within the Kubernetes cluster, and so none of these things are kind of insurmountable, but it all became a little bit messy. So we plumped for a client that a colleague of mine, Jolt, wrote, and that uses Kafka itself as the state of the current state of the cluster. And we just wrote a kind of a Docker ephemeral container, which basically on deployment runs the config manager, changes the state of Kafka, and then that container dies. So the Kafka config manager is quite a nice piece of kit. You can declare that config in YAML. You can check it into source control. It's nice and declarative. It's got a nice little thing where you can define config sets. So you might have a config set for a durable topic, or you might have a config set for a speedy topic or something like that, a fast delivery topic. So you can kind of really dry that up within that one kind of YAML file. So check it out. It's all on GitHub, but free to download, free to use. Please do use it. We use it. It's a good thing. Coming on to some more kind of specific things that we can change, we can manage. Secrets management. So Kafka has kind of two main kind of categories of secret management. You've got SASL, which is kind of username and password, kind of usual stuff that you're used to, or we've got kind of mutual TLS. Username, password, that can be a bit of a pain. Most people are storing their secrets in vaults or GitHub secrets or something like that. But when you deploy, you need to get at those secrets. So what some people do is they'll read the secret and then they'll write that into a config time at deployment time. That's a bit messy, to be honest with you. If you can avoid doing that, then do, because you want your infrastructure as much as possible to be immutable from what you had in source control. You want to tie those things together, and you want to keep them the same. You want to know that there's no variation. So what you can do instead is to actually kind of reference those things and pull them down from vaults, pull your secrets down from vaults or GitHub at runtime or something like that. That's not always possible because GitHub lives on the web. You might be behind a million firewalls and things. So you can do things like mutual TLS. If you want to use mutual TLS, Kafka is a multi-node system. It's always going to be a pain to manage because you've got servers and clients, mutual key exchange that they need to understand each other. They need to communicate. So you've already got a number of moving parts, and so if you're not doing infrastructure as code, you're probably in a world of hurt if you've got to do mutual TLS. But anyway, how would this work in an ideal world? So in an ideal world, we've got some kind of bunch of Docker containers that are doing something, whatever that might be. We've got our root certificate authority. Maybe that's something like Let's Encrypt, or maybe you've got a vendor product like Venafi. And at startup, there'll be an init or a sidecar container alongside each of your services, and that will go and grab the certificate from Vault, and then that sidecar will die, but it will be placing that certificate in the file system for your pod, for your service. And then once your service starts up, it doesn't know any different. It doesn't care how the certificate got there. It's now got it on its file system, and it's able to do its TLS exchange with Kafka. Now that allows us to kind of decouple the security and harden that init container separate from a service, and it allows us to kind of dry that up as well. That init container can be the same for all of those kinds of services, assuming they're getting their secret from the same place. So if I can just plug another colleague of mine, a guy called Mateus, he did a presentation on just doing exactly this at HashiConf. I think it was either last year or the year before. So that's on YouTube. Check it out if that's something you want to do. He kind of walks you through an example. I think he's braver than me. I think he does a live coding example as well. But what about in the Kubernetes world? So you've got a few more options in a Kubernetes world. So you can generate the certs in Vault using infrastructure as code. And then you can create a sealed secret in the Bitnami operator within Kubernetes. So this works rather nicely, actually. So when the service wants that encrypted secret, Kubernetes will actually hand it to them at runtime. So, and then the certificate is then available for mutual certificates exchange with Kafka. Now, the thing with this is that it's the Bitnami operator that is encrypting that certificate, and it means you've got an encrypted version of that certificate that only Kubernetes understands how to decrypt, which means you can check that encrypted secret into your source control, which feels a little bit weird, but it makes it really nice and immutable. And the only drawback with this is that what we've seen with one client is that Kubernetes will take that secret to the grave. So if you don't do a rolling upgrade of your Kubernetes cluster, then and if you shut down your Kubernetes cluster for any reason, you will soon find out who your friends and your enemies are, because you'll have to go back to all of your dev teams and kind of go, hey, can we regenerate all of your certificates, please? Because we can no longer decrypt any of your secrets. If you're interested in doing this, the Confluent documentation on this is really, really good. So they've got a step-by-step kind of cookbook to go through with, you know, how to set up this exact kind of a cluster as well. So that's well worth checking out. Thinking about backups, so not too many people kind of think about Kafka as a system that you need to back up. They think of the data as being very, very transient. Well, that's true for a lot of use cases, but actually Confluent would prefer you to think about Kafka as if it were a database. So it's your central nervous system, it's your database. This is how they want you to think about their data. So if Kafka is a database, or is like a database, then we should have a backup plan, as Mila Kunis specifies. So the database equivalent of some kind of cloud system is, you know, a database would be running with RAID, and you would have point-in-time backups of a database. So replication within a cluster is not total resilience. You know, what if you have, you know, in these days of GDPR, for instance, what if a service is leaking PII information into a topic, for instance? You then can't keep that data. You're going to have to kind of either nix that, you're going to have to kind of kill that topic. But what if there's data on there? What if it's a mix of data? You might find yourself needing a point-in-time recovery. If you do that, don't forget to back up and restore the offsets, and have a plan for this as well. So backup options, I think Mirror Maker has had at least 2 rewrites. Confluent Replicator is a little bit better. Or there's Kafka Connect to S3, where you can just kind of plug it into the back of Kafka, and you can stream it out as a series of documents into some kind of file system. Now, the thing I really want to dwell on here, though, is how you recover from having backups. And I just want to give you a simple kind of use case of what to think about and how to avoid kind of like a runaway process kind of thing. So if we consider a kind of a fairly generic microservices architecture, these 3 services are actually taken from a recent project that we delivered for a manufacturing company in Denmark. Now, their default, the Kafka default for any consumer is auto offset reset to earliest. So if I don't have an offset for you, I will give you the earliest data on that topic. Now, we've got 3 Kafka topics here. We've got inbound orders, persisted orders, validated orders, and, you know, it goes A to B to C in here. Now, what if our Kafka cluster dies, but we've got a backup of it? Now, that's great. So I'm going to reinstall Kafka, or I'm going to start a new Kafka cluster if I'm using MSK, for instance, and I can reinstate the data. Brilliant. Now I'm going to start these 3 services, and that data has already been persisted for all of those 3 topics. But this new Kafka cluster doesn't have an offset for any of these 3 actors. So the order persistence service starts up and it goes, great, I'm going to start reading from the start of my inbound orders. So it's now going to start creating new records on the persisted orders topic. However, the persisted orders topic already has the previous work that it's already done. So therefore, the persisted orders topic now is twice the size that it should be. And the order validator, when it started up, it said, great, I don't have an offset. Kafka's given it the earliest offset. And the order validator is going to start its work from the start of the persisted orders topic, which is already twice the size that it should be. So the order validator is now going to do twice as much work as it would have done. And so that is now going to put 3 times the amount of work onto the validated orders topic, because there's now that amount of work. It's 2 times plus the 3rd time amount of work onto the last topic. So you see that actually, because we haven't been careful enough to think about kind of how we're going to recover, we can restart our cluster, and then all of a sudden our processes spin up into life and they start just run away, and they kind of go, great, I've got loads of work to do. Now that is a horrible place to be honest with you, because you're already in in a difficult situation because you're restoring from a backup. So something has gone wrong somewhere along the lines. So then when you're about to go, hey, great, production's back up and running. Actually, it's doing a bunch of stuff I wasn't expecting it to do. And then you go, okay, I need some kind of circuit breaker or something that I need to be able to switch this off. So this is the kind of thing that you really need to kind of just have a plan for. Yeah. Resilience isn't just about DevOps. What about the application itself? So something I like to do with my Kafka architectures is I like to kind of hard code or at least centralize the config that I'm going to be using for my producers and consumers that I'm actually creating at runtime. The reason I put this in here is that you see a lot of examples on the web of people starting to use something like Kafka, and they might have a baseline properties file, then they apply some code created property object, and then they might then apply some system properties as well that were specified at the command line. So who knows what precedents those have been applied? Who knows what was specified at the command line? Unless you're logging that out, you just don't know. And that is, I've said this more than once already in this talk, that's a bad place to be because you don't know what your current running config is unless you're logging it out. That lack of determinism, you definitely don't want that. I never want to see that. And also you can then almost specify sets of the kinds of config that you want. Maybe you want ax.all for some topics, whether it's a resilient topic, or you might just say ax -1. I don't really, or ax 0. I don't really care, just fire and forget. Another tip, please do this. Please do this. You will thank me later, I promise. Log the offset and partition as you read. So if you've got a consumer, if you log the offset and the partition as you read, you go, I've read this event. This is where it is on the topic. Because if ever you get something wrong with that event that you've read, it gives you a fighting chance. You go straight into the log. Here was the exception. I can then go back and I can query Kafka and I can find that exact event that gave rise to this bunch of errors. And I can give that document in a bug report. Somebody can run it up on their local machine and they can debug it and they can fix it. And that will give you a much faster time to recovery than it would be if you don't have it, which is, something went wrong. It's that kind of a thing. The last point I have on that slide as well is that I like to manipulate the offset myself. You can get Kafka to say, hey, look, every 5 seconds or something, commit the offset wherever I'm up to. I much prefer to manipulate that offset myself because it allows me to do composite transactions. Because usually what I'm doing is I'm reading from a topic, I'm doing a thing, whatever that might be, and then I want to say to Kafka, right, I'm done with that piece of input data, don't give it to me again. And I want to have control over that. And that's not a temporal thing. That's a I've done my work kind of thing. If you want it truly atomic with a database, that thing that you're doing, if you're doing a database operation, if you want your read from Kafka to be truly atomic, sorry, I've lost my train of thought. If you're doing something that's transactional with Kafka, you don't want Kafka to be storing your offset. You need to store that offset with the database system that you're doing the commit onto, because then you can have a composite commit on the database system that you're committing to, rather than with Kafka, so that you roll back either the change to the offset along with the data, because you've still got the opportunity for kind of a failure to happen if you still allow Kafka to commit the offset at the same time as the database. This is a nice example. So this is another piece of code taken from a project that I worked on most recently. We had an order received topic, and this was a TypeScript project. Anyone who's a Java programmer will think this looks like Java, because it really does to me. So therefore, it's a TypeScript project. So we had types at compile time, but not at runtime. So they were just JSON objects. So we said, well, actually, we might as well just use JSON on the topic, as we're kind of moving these things around. But we didn't really want to have kind of like a schema and things like this on top, because it's just JSON and it makes life a lot easier when you're working with JavaScript. But you do have options. So what we did is we coupled the runtime type to the topic name. So the topic name here is orders order received. Order received says that's the order dash received says the that gives the class name, and .1 is just an arbitrary version number that we gave to it. So when the schema for an order received class kind of moved on, we would bump the version number up, so that what that meant is that whenever we were asking for order received, where can I find that topic, we'd always ask this class, and we'd get an object on the topic that was compatible with the class version here, because you don't have real compiled classes. So that is a very cheap and easy way to make sure that you kind of keep your the rollouts that you're doing of code in lockstep with the data that is currently stored within your Kafka cluster, so you know that you can always rely on that compatibility. Thinking a little bit about monitoring, I think I'm going to try and speed up a little bit because I've been going through this a little while. Think about monitoring. So if you're not familiar with lag, lag is how far behind the top of the topic any given consumer is. Lag is a really great statistic for you to find out what the health of a consumer really is. You want to monitor that lag, you can alert on it, and graphing it is even better. And I've got a couple of graphs I'm going to show you. But it allows you to understand patterns in your application as well. So if I give you an example, this is from a project most recently, and we were polling Amazon for new orders because they couldn't push them to us. They had a REST endpoint and we had to go and get them. And every REST call we would poll it every 10 minutes and say, give me all the orders that you had since the last time I polled. So we thought, well, this is orders, so this is going to smooth that out really nicely all along the day. But actually it didn't, because if you look, the orders that we were seeing, we would get spikes at certain points in the day. So we didn't realize this, but we were actually subject to a batch system on the other end of this that was kind of dumping orders on us when we were expecting that to be nice and smooth throughout the day. All of this data, I mean, you can find that. I mean, orders ended up in a database table, you could query it, and the data is there. But just monitoring the lag of where we were getting spikes of data dumped on us allowed us to kind of just see that and understand our application in a new and interesting way. Another good example is an event storm. So this is an event storm that we had. If you're not familiar with the term event storm, this is where, at its simplest case, you might have two services, service A and service B. A sends B a message, and for whatever reason, B doesn't do anything in time. A then sends that message again, and then again and again and again. And it just makes B slower and slower and slower. And A might keep on sending events back to B, thus making a bad problem even worse. So what we had here is that we had a small batch process that was creating new events to then go and query Amazon. And so what was happening is that during Black Friday, in fact, is that the query to Amazon became very, very busy, and so it couldn't respond in time. And so the batch process kept on saying, hey, can you go and do this thing for me? Can you go and do this thing for me? And then the query to Amazon got slower and slower and got further and further behind. And so actually what you can see is that the two graphs there, there's one service in blue, another service in red, and they were making each other worse because actually there was a little bit of a feedback loop in there. So the moral of the story is that actually you can see that happening quite clearly from a graph. And you can also add monitoring thresholds and things like this. But also the moral of the story is don't mix batch and event streaming. The things are like oil and water. They do not play well together. What we ended up doing here was actually altering that batch process to be a bit more event driven, And so it was able to kind of be a little bit more kind of, they played a lot nicer together after that. But we did learn out, I think there's something like 90,000 events that really shouldn't have been there. And a lot of them were duplicates as well, which was nice. Thinking about tooling as well, I won't go into too much detail there because you can read the slides afterwards. I think they'll be published. One thing I will say though is that you can tune your lag thresholds accordingly because different consumers will tolerate lag at different rates. So things like a fast-moving topic, we could probably have lag for ages, or maybe you don't want lag on that topic. But maybe there's other topics that are lazy or they get a big amount of data 3 times a day or something. So therefore they can afford to have lag because they will have it 3 times a day. So there's not a one size fits all in terms of what your monitoring threshold for lag metrics are. You need to have a little bit of an understanding as to what your application needs for that. Yeah, you can read those slides afterwards. There's not much more to add than what's on the slide there, to be honest with you. But feed those stats into your favorite monitoring tool, Prometheus, Grafana, whatever it might be. There's some tooling around here. Yeah, I've got 3 slides left, and then we'll do some takeaways and some questions. Conductor is a great tool. It's free for development use. It becomes a little bit more expensive for commercial licenses, but you can look at all the things you need to look at, cluster health, you can write to topics, you can tail topics and things. It's worth mentioning Confluent Command Center as well. If Confluent is your bag, then the Command Center does a pretty good job of showing you stats around your cluster, as you would imagine from the makers of Kafka. One of the open source tools that we used was AKHQ, and that's a screenshot from AKHQ. The UI was a little bit buggy. It was still a little bit immature when we were using it. But the main thing you want from your tooling on this side is basically you want to be able to produce messages, consume from a topic or a partition in real time, and you want to have a look and be able to manipulate a message as well. Those are the main things. If you can do that, then those are the main things that you kind of really need to do. Okay, I think I've got 2 minutes left. Is that right, Alexander?
Yeah, but no worries. We can go over time.
I have 1 slide left. So my key takeaways are use a provisioning tool and version the config. I mean, that's not just for Kafka. Can we just agree that that's just for everything, please? That just should be now. Do the same rigor for Kafka as you would a production database. Backups, secrets, that kind of stuff. And again, topic partitioning affects the ordering, which can affect your application logic. I provisioned in a recent project, we had provisioned different environments at different times, and they had different pieces of config. And the last environment to be provisioned was production, and that had a different number of partitions. And it turned out there was a bug in the way that we were writing offsets back for multiple partitions, which meant that we couldn't actually provision production, and we couldn't understand why at all, because we had actually not had the right amount of hygiene. And it's one of the reasons I wrote this talk, actually, was because that was our own fault, that we hadn't had the hygiene for all of the environments, and we really do need that. Tame your application config, put that into some code, check that code in, name that code nicely, like resilient topic config or speed topic config or something like that, but really materialize that, and don't mutate that at runtime or anything like that. Keep it clear, keep it immutable, keep it consistent. And when you're on call and you need some help, monitor the key metrics, lag, replication counts, broker health, that kind of stuff. Kafka is scalable and observable. So observe it, basically. Take advantage of it in your architectures and your data platforms. And ultimately your stakeholders will love you for it because they can see what's going on, and you can give them pretty graphs and dashboards as to what's happening within the state of their application. And stakeholders love that stuff. So, and that is the end of my talk.